So in 7.5, we're going to talk about some additional quadrilaterals known as trapezoids and kites. So trapezoids are quadrilaterals that have exactly one pair of parallel sides. So remember, a parallelogram has two pairs of parallel sides. A trapezoid has one pair. And we need to know the vocab, right? So the parallel sides here are B and C and A and D. Okay, notice the parallel symbol, okay? And then the other two sides, those are called legs, okay? So real quick, the parallel sides, we call them bases. Sorry about that, I forgot about that. We call them bases, and the non-parallel sides are called legs, okay? And then where the legs and the bases meet, we have angles that are formed there. So we have base angles. We have, for example, angle A and D, and they go with this bottom base. We have angle B and C, and they go with this top base right here, okay? And I think that's it for this slide. So then we go to a specific kind of trapezoid, which many of our questions are going to come from, but we do have, there's all sorts of trapezoids, but we're going to focus on this one, which is called an isosceles trapezoid. Now, the definition for an isosceles trapezoid is a trapezoid whose legs are congruent. So the two legs are equal, okay? And again, there's some things we're going to be able to know once we know it's an isosceles triangle, for example. So this slide tells us all the different things that, we know because something is an isosceles trapezoid. Now, remember, a generic trapezoid is still a four-sided figure. It's a quadrilateral. Its interior angles add up to 360 degrees, and it has one pair of parallel sides. This extra information on this slide pertains to an isosceles trapezoid. So it says if a trapezoid is isosceles, then each pair of base angles is congruent. So what they're telling us here is that angle A, okay, is going to be congruent to angle D, because these are the base angles for base, let's call this base 2. And we know that angle B is going to be congruent to angle C because they're the base angles of, let's call it base 1. Okay, remember, we got two bases here. The bases are those parallel sides. In the next theorem, it says that if a trapezoid has a pair of congruent base angles, then it is an isosceles triangle. So if I see a trapezoid, I know it's a trapezoid because I know the BC and AD are parallel, so those are my bases. But if I see that they have one pair of base angles that are congruent, then I know that this is an isosceles trapezoid. So I can conclude that it is. And then the third one says a trapezoid is isosceles if and only if its diagonals are congruent. Now, what's pretty cool about this is in an isosceles trapezoid, the diagonals are congruent. This is similar to a rectangle. In a rectangle, okay, the diagonals are congruent as well. One also interesting feature about this is that this piece here is going to be equal to this piece. Like, let's say wherever they intersect, right, the smaller pieces are going to be congruent and the longer pieces are going to be congruent as well. Okay, and so again, they don't talk about that, but that is a factor that comes into play here. So now we're going to go to, no matter what kind of trapezoid it is, whether it's an isosceles trapezoid or it's like another kind of trapezoid, we can connect a mid-segment within it, right? We can basically take a segment and connect it to the midpoint of the left, and we can connect it to the midpoint of the right leg here, or whatever, the midpoints of the legs, and we can connect those points. That mid-segment, or that segment there, is called the mid-segment. Now, that segment, because, once you know the definition, there's some things we know about it. So the mid-segment theorem tells us two things. It tells us that the mid-segment is parallel to each base, so XY is going to be parallel to BC and AD, and it tells us that the length is 1/2 the sum of the lengths of the bases. So in other words, XY is going to be half of base 1 plus base 2, okay? So base 1, base 2, and again, base 1 and base 2 in this problem, let's say it's BC plus AD. So it's half of that, okay? And so in any problem, I could give you the mid-segment, one base, or the other base. There's three things that we can insert here. I can give you two of the three and have you solve for the other ones, okay? Another way to look at this formula too is you can also say it's base 1 plus base 2 divided by 2. If you prefer, you could do divided by 2 instead of times a half. Now, kites are interesting because kites don't have any parallel sides, okay? So there's no parallel opposite sides in a kite. A kite is simply a quadrilateral, okay? Now, what makes a kite unique is it has exactly two pairs of congruent consecutive sides. And the word consecutive really is important. It's basically saying here's one pair of consecutive sides that are congruent. Notice they're kind of attached to each other or adjacent. And then here's another pair of consecutive congruent sides. Notice none of those are parallel to each other. There's some interesting facts here. Again, it's a quadrilateral, so we know that the interior angles still have to add up to 360 because it's a four-sided figure. But one thing we do know is that this angle that's formed here by connecting the unequal sides, like here, these two angles are congruent. So in this triangle, or in this kite, angle B is going to be congruent to angle D, okay? And these theorems is where that comes from. So again, I kind of jumped the gun there, but basically if a quadrilateral is a kite, there's two important facts on this slide. First of all, if it's a kite, the diagonals are perpendicular, okay? Now that is similar to something you learned about a rhombus. So this is like a rhombus, okay? This fact. Diagonals are perpendicular, like a rhombus, and then what I was just talking about, that exactly one pair of opposite angles are congruent. And the pair that are congruent, again, are the angles that connect the unequal sides, okay? So angle B and D are congruent, but angle A is not congruent to angle C, okay? A and C are completely different. All of them, A, B, C, and D, will add up to 360 degrees, okay? But only B and D are equal. A and C will never be equal in a kite, okay? Another kind of cool fact about the diagonals, I'm going to go up. What's interesting is that this diagonal, the one that connects the unequal angles, does have a really cool fact too, in that that particular diagonal bisects the those angles. So in other words, that diagonal bisects that big angle A into two equal angles, and it bisects C into two equal angles. So it's an angle bisector, and that's unique to that diagonal. The other diagonal, BD, does not do that. Okay, so again, another kind of additional fact. So now we're going to work some problems out talking about how we know it, right? Specifically. So when I look at this problem and I see that BC is parallel to C, or BA is parallel to CD. So I know that I'm dealing with a trapezoid in this problem, okay? So now I'm going to look at the legs of this, and I notice that the legs are congruent. So CB and AD are congruent. And so I know that specifically I'm dealing with an isosceles trapezoid. So again, if I'm dealing with an isosceles trapezoid, I know that my legs are congruent, right? I know that my base angles are congruent as well, okay? And I know that my diagonals are congruent, right? So these are three things that I know as soon as I know something is an isosceles trapezoid. So in this problem, because I know my base angles are congruent, I know that if C is 100, then D is 100. Now, I know all four angles have to add up to 360. So if I subtract 200, which is, angle C plus angle D, I'm going to be left with 160 degrees between angle A and B? Well, again, angle A and B are equal as well. So if I divide 160 by 2, I know that angle A and B have to be 80 degrees each, okay? Now, one interesting thing, if you notice, is this base angle plus this base angle is supplementary. It adds up to 180, and that actually is a fact that we're going to observe and find. So again, in isosceles trapezoids, okay, the different base angles are actually supplementary. So again, we're going to go to the next problem. We're going to ask ourselves, okay, what are we given here? I notice that FG is parallel to EH. The other two sides are not parallel, so I know that I'm dealing with a trapezoid. Okay, now again, I'm going to look at the legs, and I see that my legs are congruent. So I know this is an isosceles triangle again. And again, or not triangle, sorry, an isosceles trapezoid. And so, man, having trouble spelling isosceles today. I'm not sure why. Isosceles trapezoid. And so again, I know that it's isosceles, which means, right, I know that my legs are congruent. I know that my base angles are congruent. And I know that my diagonals are congruent. And so again, I come over to this problem. They tell me that my base angle H is 49, so I know E is 49. Now, I could do 49 plus 49, and I could get 98. I know all of them add up to 360. So I'm going to be subtracting that. So I'm going to get 262. And when I divide by 2, because I know angle F and G have to add up to 262, but I know that they are also congruent. So if I divide by 2, I know they're 131 each, okay? Now, I could have saved myself a little time because of the pattern I observed in the last one. I observed that those different base angles are supplementary. So if I did 180 minus 49, right, I could have gotten 131 as well and saved a little bit of time with the math. Again, just patterns that you're going to observe and you can apply. Okay, and then this last problem here, well, not the last problem, but this next problem, we notice once again that we have a trapezoid because we have one pair of parallel sides and we have equal legs. So once again, we have an isosceles trapezoid. Okay, so we have an isosceles trapezoid, and we know all those things we know about it. But here, the lengths they're giving us, the 21.9, that's talking about parts of the diagonals. So the fact that I really want to know here is remember that the diagonals are congruent. So what this is telling me is I know that FM, or they call it MF, let's do that, MF is congruent to KJ for sure, right? Now the problem is they're not really asking me. I know that MF is 32.7. KJ, I really don't know, right? Because KJ is KB plus JB. And so they gave me KB. So 32.7 equals 21.9 plus something. And again, I'm trying to figure out, all right, well, what's, JB or whatever. So let's do that. If I subtract 21.9 from both sides, right, I'm going to get 8, I'm going to get 0, I'm going to get 10.8. So JB equals 10.8 here. Now the question is asking me FB, but remember we sort of had this conversation already before a couple slides ago. Not only are the diagonals congruent, but remember I told you that the small pieces were equal to each other and the longer pieces were equal to each other. So if KB is 21.9, so is this one, okay? And if JB, we figured out, is 10.8, then FB is also 10.8. And so that's how we would get the solution to that problem. Again, here now we have a kite question. This is our first one. And again, remember that when we have a kite, there's certain facts that we know, right? So in a kite, we know, again, we know it's a quadrilateral, so we know all the angles have to add up to, all these major angles, these big ones, okay? They add up to 360 degrees. But one cool fact about it is that we know the angles that connect the unequal sides are congruent. It's something we know. And we know that our diagonals are perpendicular. So we know that our diagonals are perpendicular, right? And we know that one pair of opposite angles are congruent. And the pair in this problem that are congruent is the big angle right here and this large angle there. Those are the ones that we know are congruent. Now, with that said, obviously there's some smaller angles there. So they say DAB is 54. So D to A to B, that's this here, is 54 degrees. They tell you that CDF is 52. CDF. So this little piece is 52. Let me kind of erase. This little piece here is 52. And it wants the measure of BCD, this large angle there, okay? So what I have to do is think about what I've got going on here. I mean, I only have one big angle at the bottom. I know angle A is not equal to angle C. So other fact is, remember, my diagonals are perpendicular. So that angle right there, I know is 90. So if I treat this as I'm just kind of considering this particular triangle by itself here, then I know that these angles are 90 plus 52. And so it's 142. So if I know the interior angles of a triangle have to add up to 180. So I'm going to get 38 degrees. So what happens is when I come over to here, I'm going to get, kind of fix it. This is 90, this is 52, and this one right here is 38. So again, what they want is this whole large triangle. Well, remember that I told you that we know this angle over here, this big angle B and this big angle D are congruent. That's kind of like a fact about kites. The other thing I told you was the diagonal that connects the angles that aren't the same. That diagonal is a bisector, an angle bisector. So that diagonal bisects C into two equal angles. So angle C is actually 38 plus 38, or 76 degrees. And when we say angle C, what I mean is angle, let me do it right, is BCD, okay? Angle BCD, which is this large angle there. So angle BCD equals 76, okay? So this problem is not in your slides. We stopped before this one, so you can skip this problem, okay? We're going to skip this one. If we need to, we'll add this at another time, and we'll add it to your notes, and we'll go over it. But we skipped it, and you don't have to worry about doing this one.